Okay, so what I wanted to talk about today is the concept of a reversible process. So, what you might have heard is that a reversible process is a process that happens slowly, and a irreversible process happens quickly. So, we can write that reversible slow, irreversible fast. Now, this might be good for some people, um, but if you're like me, this is not good enough. To me, I consider the piston. Let's say you have this piston right here, and you have your gas in here. If you were to compress this piston very quickly from this point here to this point here, very quickly, then why would you not be able to just wait for this to equilibrate, then release it back again and let it go back to the original point? It should be the same as with the reversible case. The reversible case, you have the piston still, but you let the piston compress to some other point here in small steps, ideally infinitesimally small steps. But in that case, this is the slow case, that's reversible. But in the case where we go from this point to that point in one step, that's irreversible. But why? Because in both of these cases, if we have a sealed thing here, it should be able to return to the original point again. It might be said in the slow case, for example, that the system is able to reach an equilibrium at every step of these points. So that is why it is reversible. But why would it be important that it reaches equilibrium at every point of the step and not reach equilibrium at the end point, at the start point? Why is that? Well, after many minutes, hours of thinking, it isn't the first day I'm thinking of this, but it's today that I finally reached this point of understanding, is that it has to do with traceability and not necessarily the quickness of the steps. Consider this case. You have this graph, and you have some value here, call it a value v, and you have some progression here, progression p. Let's say you started off here, and in the fast case you just ended up here. So from this point or progression here to that point, you had this change happening quickly. You might say, okay, so we just went along like this. So that's how it goes. but that's not necessarily how it goes. It might be that there was actually an exponential function here. You wouldn't know because you only know the start and the end. So that is actually the point of this slow versus fast. In the slow case, between these points, you can know every value in between these points. So then, starting here, you know how to go back down to here. It might be the case that you cannot go like this. You cannot go along a straight path in this graph. You need to go along this path to reach this point. Or if you don't do this path and you try to do this path, you might be blocked by something here, or it might level out because it hits something at this point that it doesn't hit when we go along this path, if you can understand what I'm saying there. So that is actually what makes something reversible or irreversible. When you have less data on how things happening, you cannot retrace your steps in a very certain and decided or a knowable way. You cannot know what happened between here and here, but if you did it very slowly, you can know exactly what happened here, so you can try to undo this movement, while you cannot do that if you don't know how this change happened. So that is it. That is what I wanted to tell you today about reversible versus irreversible processes. Thank you for watching.